Before the coffee break, we had the chance to hear the very interesting presentation by Lev. He already discussed some of the properties of the Erlang language, of the Erlang VM. In my presentation, I will try to discuss them quickly again, but later I will focus on showing some of the use cases for Erlang. As I have explained before, there are quite a few Erlang factories around the world nowadays. On those, at those conferences, companies would present how they used Erlang. Researchers would present some new interesting projects. But it also turns out that not all the companies that do use Erlang admit that that's the technology in their technology stack. Some of those maybe feel like this is a competitive advantage. Some others just didn't have a chance to present, which is why I think that it's important to actually educate others how we use Erlang, where it has been put in production, what was the effect. And so my presentation will just focus on some of the presentations you could find on erlang-factory.com website. I have stolen some slides from different people here, but my intention is to once again just highlight some of the interesting, in my opinion, use cases. First, I have few slides just putting features of Erlang here. Erlang, being a functional language, gives a nice high level of abstraction. So together with pattern matching, we get quite concise, readable programs. I very much like the comment by Lev that Erlang code is like what you see is what you get kind of code. It has support for concurrency, which very much helps with scaling systems on multi-core machines. It has soft real-time properties, which is again a very nice advantage as well in the real-time web, as we have heard, but also in some other areas like telecoms, where soft real-time systems are needed. It's robust because it has a very interesting approach to consistent error recovery. I will not go into details of all this in my slide because we don't have enough time to discuss this. But here I just want to highlight some of the interesting features which actually add up to a platform on top of which interesting systems and solutions are built. Distribution is definitely one of those. It is built into the Airline VM. It's relatively easy for a programmer to communicate between the nodes in a cluster, in a ring. So systems like RAIAC, distributed database, are relatively easy to build. At least the distribution layer of it is very nicely expressed through Erlang syntax. Another feature, hot code loading, it was mentioned already today, could be used in production, which is nice, but it's also very, very nice feature for developers, as the development cycle is short. You just add a new feature to your code, recompile, and load a new module into your system that you are testing, which is a very nice feature which shortens the each iteration of development. Erlang is not a ghetto. It has external interfaces towards other external systems and technologies. It is quite portable, as you already have Erlang running on Unix, Windows, VxWorks and such. And the last but not least is a feature of support for symmetric multiprocessing, where Erlang VM can take advantage of all the available cores of your CPU. I guess your laptops today have dual-core Intels or quad-cores already, but in production systems you already see 24-core CPUs. So how do you take advantage of this new power of your hardware? Thanks to the feature of VM, which allows spreading Erlang processes across all the available cores of the CPU, Airline VM can actually take advantage of these new hardware architectures. Okay, this was just a short introduction, and now on a couple of slides I would like to show how different industries had a chance to use Erlang with success. So we have games, messaging, databases, cloud, automotive, just to name a few. First comes a slide about Demonware, which is an Irish company where they use Erlang as an infrastructure for the online game Call of Duty Black Ops. They have quite a few users online, as you may guess, over 2 million concurrent users. Erlang is being used here as a core server for controlling Python tasks. So logic of the game is in a Python task, but all the distribution layer, all the TCP handling, this is done by Erlang. So interesting use case where both technologies combined together allow them to serve such a mass of online users. Another example, Wooga, where they use also Erlang for social gaming. This is quite a popular set of games that Wooga has made. As they report, they actually grow, so this is maybe already a bit outdated. But having 1 million daily users generates quite a lot of traffic. Having so many requests per second, and this is online gaming, creates a lot of challenges. So in this particular case, Erlang has been used to store user data. Erlang processes encapsulate state very nicely. The number of Erlang processes that we can run on each machine can be up to millions. So this is actually the way that Erlang has played for an advantage for Wooga backends. We have also Erlang being used in messaging world, which is actually quite natural due to the nature of Erlang processes and message passing. For example, Facebook chat feature, which was a while ago, but it has been implemented with a bit of help from Erlang, where billion of user messages were processed per day, and for each user in the system an Erlang process was created, and again it was not only pushing the messages but also keeping the state of the user. And by the way, Facebook chat team got an Erlang User of the Year award in 2009, so this was also good news for them, but also for us, the Erlang community, because thanks to them a lot of people were actually looking into Erlang. There's quite famous XMPP implementation in Erlang, eJabber-D, which implements a lot of extensions, and it takes advantage of Erlang features like distribution, fault tolerance, cross-platform, and so on, which is why quite a few companies around the world actually adopt this. Here on my slide I just put a few, like Jabber.org, Japster.pl, Asha Class, but there are quite a lot of others too. Another example of how Erlang was used in messaging, WhatsApp. They are actually a very bright engineering team. They have tweaked the Airline VM slightly to push it to its limits. All of those modifications have been published on GitHub, so they are available. Not all of them are part of the mainstream, as far as I know, yet. But what they have done with Airline VM is incredible. We are talking here about quite modern hardware with 24 logical CPUs, a lot of RAM, as you can see. And those are the numbers that they shared with us a few months ago during the Erlang Factory in San Francisco. Almost 85% CPU utilization across all 24 logical CPUs. This is really a lot. With 2.8 million users connected per box at peak time. Per box, this is really a lot. And again, of course, this required a lot of skills of the engineering team as they were tweaking it, the VM as well. But Erlang has been used as a baseline platform for the system. Few slides about database solutions built on top of Erlang. We have Ryak here, a masterless distributed database which is scalable. You can add as many nodes to, well, as we have heard actually today during one of the presentations. There's RAYAC core used here as well. So interesting project, interesting product. There are quite a few companies out there using RAYAC already. I just put here a few names like Comcast, Yammer, Voxer. Also, some of the classified ads are using Erlang to store images. RAYAC to store images like slando.ru. So this is an interesting database to look at. There's another one, CouchDB, also implemented in Erlang, which is schema-free, and it has interesting replication model with bi-directional conflict detection. So again, this is one of those NoSQL databases, and as sometimes we refer to them, which is being used in modern web development, but not only. And at the very beginning, it was built on top of the Airline VM. Some of the services out there that use Erlang for different purposes, like GitHub, where Erlang is used to dispatch requests to Ruby machines, the business logic of GitHub being implemented in Ruby, but Erlang serving as this first layer. Heroku, again, Erlang used for distributing traffic, for automatic scaling. So Erlang is now being more and more used in cloud environments as we see it. The growth is quite interesting. In this slide, which I borrowed from 37 Signals, the interesting thing is Erlang and C comparison. Because when people try out Erlang for the first time, they sometimes say, okay, well, this is Airline VM, right, so code is interpreted, this will never be fast. But interesting measurements done on the IO-intensive, network-intensive applications with some degree of concurrency show that that's not necessarily the case. Here we have two free implementations in different languages of the same chat feature of Campfire, and the interesting bit is here that Erlang can serve almost as many requests as C implementation would do, having a bit less code base to do the same. The latency is also very interesting, and instead of using a lot of OS processes, which are not always easy to coordinate, this is using just one Erlang VM process. And within the Erlang OS process, a lot of Erlang processes will be spawned, each one to probably serve each new TCP requests. But this is the interesting part. We have less code, we have less OS processes to work with, but still, at least the benchmarks that I've been doing show that this was not so much slower than C implementation. And another use case I put here on my slides, it's a QuickCheck. It was also mentioned here today. It's used for property-based testing, which is an interesting approach, quite different from unit testing that is widely adopted. Here we actually generalize, we have some properties defined first, domain defined first, and then we can generate a lot of use cases for free, meaning it just takes time to generate them, but it doesn't involve the user. It's automatically generated in a random fashion. And where this has been used? Well, in very many projects we are using this on day-to-day basis, but one of the interesting use cases for this is automotive industry. The QuickVic company behind QuickCheck has shared quite a few presentations on how they use Erlang and QuickCheck to test and verify modern cars, where you have, tens, if not hundreds nowadays, so-called ECUs, which are small units in a car, which need to communicate with each other. They are responsible for every small operation of your car. And now, how do you make sure that all they talk to each other, there are no bugs, and actually that if those processors come from different vendors, that they still can talk to each other? So no longer talking about scalability and fault tolerance, here talking about interesting tool, QuickCheck, for testing, but done in Erlang actually helps testing also Erlang programs. So those were just some few examples. I just wanted to help you kick off exploration of Erlang-factory.com website, because this is where we put all of the slides, most of the videos that were captured during factories. So you can learn quite a lot about how people use Erlang, what are the trends, and I really encourage you to dig more about it. And I think this was really it that I wanted to say today. So thank you. If there are any questions, I can probably still take them now, as we have still quite a few minutes. But I will also be here till well, even tomorrow, so we can keep on chatting, keep on going. Thank you.
I have a question about Vuga use case. As I understand, they use Erlang as key value storage, right?
I know that they actually grow the Erlang team quite a lot, and they find more and more use cases for Erlang at Vuga. So probably what I know about Vuga is already outdated, as they keep on using Erlang for different purposes.
Oh, okay. Thank you.
So as we know, Erlang emerged like in mid-80s, and since then it kept basically a rather low profile and started to gain popularity right after 2005, when we all know free lunch was over, yeah, and we couldn't anymore gain product performance from raising CPU clock times, right? So people turned to technologies that utilize properly multi-cores. But since then, virtues of Erlang were adopted by other languages, like, as I said, Java, Scala now have Akka, which uses the same actor model, message pace and stuff like that. So don't you think that Erlang loses its chance to become really mainstream language, because now other languages use this, provide the same killer features of the language, but they more widely spread among developers. So.
Yep. This question is being asked over and over again. I think it was also asked before in the previous presentation. I think that Erlang has some niche here. It depends how you define a mainstream technology. I wouldn't use Erlang for everything. I would just use it for some class of problems where it really shines. So I see that Scala being tightly integrated also with Java world, and probably having lower cost entry for people that come from Java is natural choice. But I also see Erlang having some interesting features which are not in other languages yet. And this makes it actually quite tempting proposition for developers anyway. So I don't see Erlang really losing here. I see tremendous growth of interest when you see the numbers at the conferences, the number of companies hiring, looking for Erlang developers, a number of new projects popping up on GitHub or other places. I see it growing, and that's just a trend that we observe for quite a few years right now. So this discussion will probably continue, whether Scala or Akka or other technologies are better suited than Erlang for certain class of problems. So Erlang, and I think this will just keep on going for now. I wouldn't say that there is like a one victory here, one winner here.
Thank you.